Hi guys, welcome to this video on date operations in Pandas data frame part 1. In this video, we are going to look at why we need a special date time data type while working with date columns in Pandas data frame. And we will see how to use pd.to underscore datetime effectively, which is a function which is used to convert a string column to a datetime column. And once we convert a string column to datetime column, we will see how do we extract different date components using .dt accessor. For example, if you want to extract year, month, day from a date column, how can we do that using .dt accessor? And we'll also see how we can use a resample method instead of group by for trending analysis. For example, if you want to do month-wise revenue calculation, year-wise total number of runs, code, etc. and all, typically we use group by operations, but why we should use resample instead of group by, we will check that as well. And finally, we will also see how to compute time difference between two date columns. So how do we subtract two date columns and extract, let's say, number of days in between or number of hours or seconds in between. So for this, we are going to use a dataset which is called as online retail dataset. I'm downloading this dataset from a website called UCI Machine Learning Repository. So when you search for online retail UCI, you'll able to see the link online retail UCI Machine Learning Repository. So in this link, you will able to see a download button, and it will give you an Excel file. So that Excel file is what I'm reading it here using pandas .read underscore Excel. So in this data frame, we have invoices, that is purchase details from different customers in a particular store. So we have invoice number, and under that invoice, what are the different items that customer has purchased. So for this invoice 536365 that you can see in the first few rows, there are different items that is stock code purchased under this invoice, and what is the description of that particular item we have, and what is the quantity, and we have invoice date which is common to a particular invoice number. So for this video, we are going to play around with this invoice date column. Let us look at the column data types. Before that, since we have quantity and unit price separately, we'll multiply these two so that we will get to know for particular invoice, but for that particular product, what is the total price the customer has paid. So we are creating a new column called total price and multiplying unit price and quantity. So this will be useful in the coming analysis. When you look at the column types using .dtypes property, so against invoice date, you see a special type called as datetime 64. So here, Pandas has automatically recognized this particular column as date column while we are reading it through Excel files. At times, this might not happen. It will read it as objects, that is, it will read it as string columns. For example, let me read a data set from a CSV file. So in this data set, we have runs code by different players across different ODI matches. So when I look at the column data types here, so you'll able to see the match date column is of type object. That is, it is considered as a string column while reading it from a CSV file. So what do we do? Ideally, it's best to convert them into datetime columns manually. Either you can use some date parameters while reading the CSV file. That is one option. The best option is to manually convert it using pd.to underscore datetime. So I'm going to create a new column called date, and I'm going to use a function called pd.to underscore datetime, and I'm going to pass on the column which contains the date information, which is match date in this particular example. And this would do, Pandas will automatically identify what is the type of the format, the date format. So sometimes we will have year first, month second, and then date as a third parameter. or the format of the date could be such that date slash month slash year. So Pandas will mostly automatically detect the format by itself, but it's best to feed it manually. So for example, when you look at the first few rows, you'll able to understand what is the format in which we have the date information. So it is month in numeric format, hyphen, day, hyphen, full year. So we have 2010 as such as 2010, not as just 10 as such. Last 2 digits alone, it's not there. We have the complete 4 digits information here. So it is advised to provide the format manually. So how do we provide that? So here the first digit corresponds to month. So percentage M. So we have a hyphen here. So I'm providing hyphen here as well. Then we have day, 16th, 1, 16, 10 like this. So percentage D. Then again there is a hyphen here. So I'm going to provide hyphen here, and then we have full year 2010. So it is capital Y. That's it. So this will create a new column called date, and it will be of type date time. So we can look at the types of each of the column here. So match date, which is the original column, is of type object, whereas date column, which we created just now using pd.to_datetime, is of type datetime64. Sometimes you might have hour and minute details as well. For example, let us pick another data set. So I'm going to pick tweets data set. So if you look at the date columns in this particular data set, so we will have created at the year, hyphen, month in digits, hyphen, day, then there is a space, and then we have hour, colon, minute, colon, seconds. So when we convert such column, we have to provide the parameters for hour, minute, and second as well. So for example, here I'm going to create a new column called date using pd.to_datetime. I'm going to take the original column which is created at the format in which the date is provided here is it's initially year and it's full year, hyphen, and then month in numeric format, and then hyphen, percentage D, and then there is a space, then we have hour, and there is a colon between hour and minute. So hour, colon, minute. Minute is capital M, whereas month is small m in numerical format. So minute is capital M, and then again we have a colon, and again we have seconds. So hour, minute, second. So in this case, so we have year, month, day, and then hour, minute, and seconds format. So you can provide that information manually using format parameter. So now when we look at the D types, so we see the date column is datetime 64 and created at is of type object, which is basically a string column. So why should we provide this format? Is it mandatory? Not always. So for example, if I remove this, it will still work, and you will able to see that it is able to properly convert that created at into a datetime column. So you will able to see the new column that is created, and we didn't lose any information here. The reason why we should specify the format explicitly while converting a string column to a datetime column is that when you specify format, Pandas will not try to interpret what is the format in which date is provided. So the operation, the entire operation of converting a string column to a datetime column will be much faster when you provide format parameter explicitly. Otherwise, it will try to interpret each and every row, and the operation could slow down. And for a very large data set, it might even take few minutes to convert the entire column from string to date time, which is very high loading time. Whereas if you specify format, it will able to convert the same thing in within few milliseconds, depending upon the data set size. So though it's not mandatory to provide format, and Pandas way of detecting the date parameters is smart enough, it's advised that if you know the format upfront, you better provide it for optimizing the loading time. So let us look at how do we extract date components using .dt accessor. So for this, I'm going to use the retail dataset. So we are going to compute, let's say, month-wise total revenue for this particular e-commerce site. First, let's convert this dataset's granularity. So this dataset is, as of now, is at like invoice to stock code level. That is, for each invoice, we have multiple stocks purchased, that is multiple product purchased, and we have a price of each of those products individually for a particular invoice. So for example, if I filter just this particular invoice, let's take the first invoice number. So for this particular invoice, we have 7 items. So the customer has purchased 7 items together in a single basket. So we have the same invoice number and same invoice date all across, whereas the product in each of the rows are different, and we have the corresponding quantity and unit price, whereas the customer ID, country column, all those are quite same. So instead of having the data granularity at product level, that is invoice to product level, I'm going to convert this data set at invoice level. So each row will be just one invoice, and we will have the data computed at invoice level. So for that, I'm going to group this data set. So let us call it as retail underscore or just summary. So summary is equal to retail dot group by, and we are going to group using invoice date column. So here group by will be invoice number, and we want multiple other new columns created. For example, I want to know total price for this particular invoice. So we have to sum up all this and then create a new column called invoice amount. So invoice amount is equal to, so we are going to use the total price column, and then I'm going to sum it up. Likewise, I'm going to create a few other columns like customer ID. So customer ID is going to be same across all the rows, right, for this particular invoice alone. So you can just pick the first rows customer ID alone, because I just need this customer ID and it's same across all the rows for this particular invoice at least. So I'm just picking the first customer ID, and likewise for each invoice it will pick the customer ID from the first row, and then we will also pick the created at. So we'll create a date column or invoice date column is equal to the original column name here is invoice date. Same principle, I'm just going to pick the first row alone, because for a particular invoice the invoice date is going to repeat for all the products. So for now, I think this should be good enough. If you want, you can also compute other parameters like total products purchased, which is stock code. And you just simply count it. Number of rows will define how many different types of products purchased. So total unique product under this particular invoice is just the count of the stock code. So here, if you look at the summary, now we have information. So we have an error. So there is nothing like customer. Okay, customer column, we have a typo. Then another error. Still there is a issue with the customer ID, both capital. So here we have invoice number as index, and invoice amount, customer ID, invoice date, and total unique products under that particular invoice. Now let's say I want to create a few more columns. That is, what is the year for this particular invoice, what is the month, and what is the day. For example, a typical way of creating this is sometimes people used to extract just first 4 digits alone and then convert that into a numeric. And for month, you just split the date column probably by hyphen, or just take the characters next to hyphen. So that is another possibility without using any date operations. This will still do. That is, if I want to take year, I can take the first 4 digits and then move ahead and create a new column. But the problem comes in that when I ask, let's say, what if I want to know whether this particular date is Monday or Tuesday, and let's say, what if I want to use month, but not just as a numeric format, but let's say I want to have it as December, in which case I have to manually convert 12 to December and 10 to October and all. So whenever you want to extract date parameters like year, month, sometimes it might be easier for you to just pick few characters using string operation, but it might not scale for all data fields extraction. The best way is to use .dt accessor to extract different components. For example, if I want to create a new column, let's say year, all we have to do is just utilize the invoice date column, which is of type datetime now. .dt is a accessor which will help you to create more fields from the date column. So you can just see the type of different parameters that you have. So .dt you have options to create day of week and day in, you have like hour, you have a month as a name. So instead of just 12, you can extract it as December. So likewise, there are a lot of other parameters that are available in this DT accessor, which will be quite helpful. So in this particular case, we want the year parameter. So we will able to extract the year column automatically. So you don't have to use any string operations to extract year. And let's say if I want to extract month. So in the same way, I'm going to create a new column. So instead of year, I'm going to create month and .dt .month. So this will create a new column as month. And let's say if you want to know the day in which the invoice is created, so you just have to say .dt day. So this would create a new column with the parameter day in. So let's say if you want to create a month name instead of month number, so you can use summary invoice date .dt I think we have a parameter name month underscore name. So you can see so you can see it is coming as December, and if you further look at different rows, so you'll able to see in which month it falls into. So for this, at least most of the data is from December. Let's look at the last few rows. So even here, I think it's still December, but we'll able to see in between. If the month number is 10, you'll able to see it as October. So you can also just randomly pick some rows and see if it is doing a good job. Let's say randomly I pick some 20 rows. So you can see this is 01, which is January. So we have it as January here. This is 04, which is of April. So Such operations are quite effective when we use .dt accessor. At times, let's say you want to know or collect year and month together. For example, when you want to do year-wise analysis or month-wise analysis, it's best to attach your month and year together. So for example, what if I want a date column which is of having information year underscore month. So here a simplest option is to use a new function along with .dt, which is called as string str from time. So you want to extract some custom date information format from the datetime column. So in which case you can use .dt string from time, strf time, and specify what is the format that you want. For example, you can specify that I want year first, the full year, underscore I want month. So this way you will able to create a new column which is having information year underscore month. You can modify this. Let's say if you want to use the month name in short form, you can say 2011 underscore October in short form. So whenever you want to customize the way in which the date information is presented in the report or in the dashboard, this function .strf time will be quite helpful. Likewise, you can also extract whether it is Monday or Tuesday, so that is day of the week. So you can able to, so you will able to extract what is the day of the week. So all you have to do is just specify %a. So %a will tell you whether it is Monday or Tuesday or Wednesday in short form. If you use capital A, you will get the day of the week in full form. So small b is for month name, capital B is again for month name but full month name. Small a is day of the week short form, and capital A is full form of the day of the week. So like this, you can try extracting multiple parameters if you want to extract the hour in which this invoice is generated. So you can just say hour. Either you can use .dt.hour, or here itself you can say you just need the hour information. So .dt.strip time is a generic function using which you can extract whatever information you want from that particular date column, be it hour, seconds, or month, day, or combination of these. So you will able to extract those informations very easily using .dt accessor. So instead of just doing string operations, which sometimes might be quite tedious to do, you can use .dt accessor to extract different date components. Now that we have understood how to extract different date components from a particular date column, if it is of type datetime, we will do a very simple trending analysis. Let's say I want to calculate something like day-wise revenue or month-wise revenue and plot it as a line chart. Let's see how to do that and what are the different options that are available. So first thing, let's say I want to do day-wise total revenue computed, because we have information at invoice level. For example, in a particular date, if there are more than one invoices, we would ideally like to sum it up. So we want to convert the data from invoice level to day wise. So for that, ideal or simplest way is to compute date column separately by extracting or removing the hour, minute, second information, right? We just need day, month, and year alone. So I'm going to create a new column called date underscore string, because it's once we extract the components from the date column, it will be of type string. That is, the new column will be of type string. So I want to use invoice date and .dt string from time. Now I want year, I want month, I want day. I don't want year, I don't want hour, minute and second. So you can just confirm that. So we have removed the hour, minute and second information using DT accessor. Using this, now if you just say group by which column we want, the new column that we created, date underscore string, and let's say I want to take the invoice amount and then just sum it up. So you'll able to see day wise we have information, and you can go ahead and plot this plot dot line. So you will able to see day wise information. Of course you can format the picture by rotating the x-axis and all, but the important thing is, one thing that we will miss out here is it is not continuous. The date information is not continuous, because if you look at carefully the index, so we have 2010 12th first day revenue, second day revenue, third day revenue, but fourth day revenue is missing, and group by will not able to capture that information. Ideally we would like to see some missing value, or the value should be 0 for fourth, so that the line chart that we are plotting is continuous. Otherwise we might mislead the user who is viewing that particular report, because that is very difficult to identify it from individual dates from a plot, whether a particular date is missing or not. We will be showing a continuous plot, whereas the dates are not continuous, the dates are missing. So 12th December 4th information is missing. So how do we sort out this particular problem? So group by is not an ideal solution when you have to use trending analysis. Instead, we have a very useful function in Pandas called as resample. So summary dot resample is the function. It mainly takes two parameters. One is what is the frequency in which you want to compute. So here we want day wise information. So it is 1D. If you specify 1M, it is month wise. Likewise, we have different characters for week wise, or 2 days once, or 2 months once, like that. And we have to specify what is the date column that can be used. So here it is invoice date, and it should be of type date time. It should not be of type character or string or object. It should be of type date time. So since our invoice date is of type date time, we can utilize that. Now the column that we would like to sum up is invoice amount, and just say dot sum. So this will almost do the same job. So we'll able to get day wise information, but additionally on 4th you will able to see the value is 0, because on 4th the date value is missing. So Pandas is able to detect it, and it is now filling it with 0. So this is an ideal way to do trending analysis by using dot resample instead of group by. A best part is you can very easily convert this day wise analysis to month wise analysis, or if you want you can do year wise, or so you can try out with various different options. So a simple function dot resample on date column alone will able to do a lot of different analysis for us. In fact, you don't even have to extract year, month, which we did before, to compute the same thing. You don't even need to extract month, year and days separately. Instead, just have one date column which is of type date time, and then compute whatever trending analysis you want to do. Okay, so resample is quite effective and much better compared to group by, because when there are missing dates, group by will not able to recognize that. All it takes is all group by takes is unique dates and then computes the sum, whereas dot resample, since it is working on date time column, it knows that in between dates might be missing, and it will automatically fill in 0 or missing value based on the operation that you're doing, and it is quite effective, and that's a correct way of doing this trending analysis as well. So now you'll able to see that there is some zero value here, which was not clear in the earlier picture because it was continuous and it was having those values missing in between. So this is the right way of doing trending analysis. And as a final part of this particular video, we'll see how do we compute time difference between two date columns. For example, let us look at customer wise information. That is, I'm going to compute certain attributes for each of the customer. So far we were looking at information at invoice level. Now let's say I take the summary data which is at invoice level. I group by customer. So customer ID is the column using which we will group by, and we will compute certain information. For example, the first date in which the customer purchased a product. So let's take the invoice date. We can use min function to do that, because now we will able to do minimum or maximum on the date column. So it will give you the minimum date, that is the first date in which a customer purchased a product, that is each customer. And we'll also look at last date the same way using max. So now we can of course compute a lot of other information, but for this analysis using date operations, we are just interested in first date and last date alone. So what is the error? We have okay, typo here. So group by. So for each of the customer, we have one row. So customer ID is in the index because that is what we used inside the group by. And we have the first date in which customer purchased a product and last date in which the customer purchased a product. For example, this customer, I guess, purchased the same day twice. The customer has purchased, because you see there is a time difference. And for this customer, the customer has purchased in 2010. That is the first time the customer has purchased, and in 2011 December the last purchase, almost a year difference. So we do not know in between how many days they were purchased. We can compute that also separately, but this is just the first date in which the customer purchased and last date in which the customer purchased. Let's say you want to know what is the lifespan of a particular customer, and this might be a very good analysis to do. So all we need is days difference. So I want to subtract these two dates. It is possible to do that when the data type is of type datetime. So both the columns are of type datetime 64. So in that case, you can simply subtract these two columns, just like how you will do a difference between two columns if they are numeric. So likewise, since now it is of type datetime, we can do this difference calculations as well. So customers last date, that is last purchase date, and customers first purchase date. So you just do a difference. So now if you look at the data frame, you will able to see the number of days in between. So for this customer, there is only 0 days. I think towards the end, or in the customer joined 2011, and the last purchase is also on 2011, and it was only 1 day. I think the customer came in, purchased something, and then didn't turn up. Whereas this customer, as we discussed earlier, the first purchase was on 2010 and the last purchase is on 2011. So there is at least 365 days gap. So in between customers, this particular customer might have purchased multiple times that we do not know. So likewise, for each of the customer, we have the lifespan. Now, if you want, you can extract further information, because this might give you days, hour, minute, and second information, and it is of type date, but specifically it is of type time delta. So if you want any other further information, let's say I just need the days alone, the number of days alone, it's quite possible. So you can just say customer day diff and days alone. So you can say customers day diff. Again, you have to use .dt dot. I think you have days, which will be quite helpful here. So you'll able to extract only the days information, but you will lose out the hour, minute, etc. and all. So if you want that as well, what you can do is one way is to get it in minutes or seconds level, then convert that into days. So in seconds, so you can say customers day diff dot dt. It's not seconds because it will just give you 00 alone. What we need is total seconds. So the entire computation done in seconds level. So you can see you can use dot total seconds to get the entire information in seconds, from which if you want you can extract days or months or etc. You can just do some computation. For example, day diff in days format 2, because we already have one format in days. So you can take customers day diff or day diff in seconds. You just divide it by 60. So from seconds, it will get converted to minute. Again, divided by 60. So minute to hour, and divided by 24. So you divide, you get the day wise days difference here. So this will give you full information in days, along with the percentage of hours also will be included here. So it's 0.03. So it's up to you how you want to represent the hours information as well. So here it is 365.03 days. So that is how you read it. Or if you have any other way of defining the logic for days, you can use that as well. Okay. So using two different date columns, you can compute the difference. It is quite helpful in multiple places. For example, you want to know the time it took to resolve a particular issue. So you'll have issue created date and issue closed date. So you can compute that information. And for the same data set, if you want to know time since last purchase for a particular customer, so you can take one date, which is today, and then compute the difference between today and the last purchase date of each of the customer. You'll able to compute time since last purchase, and if that is quite high, let's say the customer didn't turn up for a year, probably you can give a call and give some promotion to that particular customer to again onboard them into the platform. So that's it for this particular part 1 video on data operations in Pandas. So we have seen what is the need for datetime data type. We also saw why we should use to_datetime and provide a format explicitly to reduce the loading time. And we saw how to extract different date components in .dt accessor. We saw how do we do trending analysis using groupby, which is not an ideal way, and instead use resample, which is a perfect way of doing trending analysis. And we also looked at how do we compute time difference between two date columns. So thanks a lot.